Good evening guys, so welcome to Videos Solar Academy tutorial. Thanks for watching our videos online. Please, if you haven't subscribed, please press the subscribe button and notification bell and also our update on this YouTube channel. Thank you for subscribing and watching our videos once again. Today I'm going to be considering what Neco physics practical, particularly under the branch of what optics. And this year we are provided with what? We are provided with plane mirror. As you can see here, this is the plane mirror, the drawing board. We have the drawing board here. The plane sheets. Here are the plane sheets here. So, and all other necessary material like clip and what? And the mirror holder. Using the diagram above as a guide to perform the experiment, fix the drawing paper to the drawing board. Now, as you can see now, I'll fix the drawing paper on the drawing board using sellotape. You might be given the top pins. So use the top pins to hold the drawing paper on the board at the four sides. Now, the next instruction says place the mirror vertically with its longer side resting on the drawing paper. We have to place this mirror on the drawing paper. Draw the outline of A, B to represent the reflecting surface of the mirror. Now, normally we have to place this mirror on the drawing paper to draw the outline. But to save ourselves much stress, just take your ruler now, measure the length of this mirror. You can measure it. Measure the length. So the length of the mirror here, as you can see here, is 14 centimeter. So we have 14 centimeter here. So instead of us using the drawing instead of using the mirror, we can use the ruler by measuring 14 centimeter. Now I'm going to draw a line of 14 centimeter representing the length of the mirror AB. So now we have the line AB, which is 14 centimeter, and the midpoint of the line is very, very important, which is 7. So I'm using the millimeter side of the ruler. So this is the length of the ruler, which is AB. So we have line AB. So now this is the middle point. Now let's continue with the next instruction here. The next instruction here says that place the mirror. We have done the outline of the mirror. Then draw a normal NQ to meet AB at its midpoint. Now we have to draw a normal to meet line AB at midpoint Q. Now this place is the midpoint Q. According to the diagram, this place is midpoint Q. Now we have to draw the number here. And how do you go about number? You can use set square to draw your number, but I'm going to use the protractor to draw my number now. So I'm going to place this on this now. So where place the protractor on this, making sure that the middle point is exactly on the point. Then mark the angle 90 degree. Yeah, so we have the normal here. We have the normal, which is the normal N key. The normal N key, we have N here. So these are normal according to the question here. So now the next thing, I haven't done this now. What is the next thing that we are asked to do? Draw a straight line ST through A. We have to draw a straight line ST through A. Now, draw a straight line ST through A. Now, this is our A here. The point here is A. Then we have to draw a line ST through A. Then how do you go about it? To meet line AB at the right angle. Now, meaning that we have to draw a line ST through A to meet line AB at right angle to each other. Now the first thing you can do here is to what? Also place your protractor here now on this, and make sure that the protractor middle is falling on upon A, because we are drawing the line through A. So identify this point and this point here. Ensure you have a straight line. So now I'm having what? A point, a line ST now, by connecting these three lines together. So this is X and this is what? T. So that's that about that. Now, having done that now, we are now asked to what? Measure a distance, what? The Roman 5 says measure a distance AC which is equal to X. Measure a distance AC which is equal to X, 1.5 centimeters. We have to measure a distance from A. So I'm using the side of what? The millimeter side of it. So this is going to be 0. Then 1.5 centimeter will be what? 15 millimeter, which is the same thing as what? 1.5 centimeter. So this is AC. So I'm marking a point now, AC. This is AC, my AC here. So my C will be here. And we are told that the AC is equivalent to what? Line X. So this is line X. The distance between here and here is what we call what? Line what? Line X. Line X, let me just use small letter so that you can identify it. So this is line X. So now you can even put what? If you want to put arrow there to indicate the what? The distance between A and what? C. Now from here now, having done that now, what is the next thing to do? What is the next thing to do? The next thing to do now is to draw a line CQ. You have to join this line, this point and this Q together to what? To form a line CQ. Now place your ruler on what? On the 2 points, and then join it together to form what? Line CQ. This is line what? CQ. So now you have line CQ, and this line CQ now we have, which is an incident what? Ray. You can put an arrow there showing there is an incident ray. Now line CQ, to represent an incident, place the 2 pins P1 and what? P2. You have to place the 2 pins P1 and P2. Now here you have to place the pin vertically. Place the pin vertically on the 2 lines. Yes. Making sure that the 2 pins are standing erect. So we are having the 2 pin now. So as you can see, the 2 pin are standing erect now. So I haven't done that now. I haven't done that. What is the next thing to do? What's the next thing to do now? So I've drawn the P1 and P2 on CQ. Replace the mirror on AB. Now we have to replace the mirror on AB. Replace the mirror on AB. Now you place the mirror on AB using your what? Your clip. So now I've placed my mirror on line AB now. You can see exactly on line AB. So now I've placed my what? You can see that we are seeing the what? The two pins at the back of the what? Mirror. Now I'm going to do it in such a way that to look for another what? Point here. Now the next thing is what? I've replaced the mirror on AB. Place two pins. Place two pins. P3 and P4 to be in a straight line with image P1 and P2. Now I'm going to what? Check now. The point of the meeting point where these two mirror meet at a what? At a point where they meet, when they I'll place my next pin here on where I am seeing only one pin. So which is the first pin now? This is where I'm seeing only what? I have to look in such a way that you are always seeing one pin. So this pin 3 and this is pin 4. So that's that about that. So now that's that. Now let's remove the mirror and draw the what? The next thing is to remove the mirror now and draw the straight line. Now we remove the mirror. So then after removing the mirror and the pins, so we have this is the reflected ray. Let me use another word. So now is that. So that's that about that. So now what we have here now is the reflected what? Ray. This is pin 1, P1, pin 2, we have what? Pin 3, and then what? Pin 3 and then pin 4. Now what are the things that we are now asked to what? Calculate now. So now we have to draw to measure angle what? ACQ. Angle ACQ. So this angle here is angle ACQ, which is theta. So it's labeled theta 1 here. And angle AQ. Angle AQL. Okay, we have to measure angle CQL. CQL. The angle here, the angle outside here, as what? Theta 2, angle CQL. Don't forget this our what? Our X. From here to here, you can use your ruler to draw it. So now 1 point what? In this case, this is we have x equal to 1 point what? 1.5 centimeter. So now, so having done that, now this is angle Q1 and angle Q2. So evaluate what? X minus x raised to power minus 1 and tan inverse theta 2. Now let's look at the value of our theta 1 and theta 2 here, because that's what we are asked to what. But the major focus here is what? Is theta 2. Now, but let's take the value of theta 1 and theta 2 and let's see what we have. Replace your so we have here, this is 75, 76, 77, 78. So theta 1 here is what? 78. Now let's look at theta 2. Let's look at theta 2. When you place it like this, you have a 0 degree now. This is what? You can see this is also 78. Very good. So it means that this is very correct. 78 degree. Theta 2 is also what? 78 what? Degree. So that shows that what? Our what? Analysis is very, very what? Correct. This shows that you can see this is theta 2 minus to what? Is equal to theta 1. Meaning that this is alternate angle. This is two parallel lines. If you extend this one now, these two are two parallel lines. This angle here is equal to this angle. We have what? 78 degree. So we are asked to find the x inverse. In each case, find the what? X inverse, which is what? 1 over what? 1 over 1.5 centimeter. And then we have to find tan what? Tan theta what? 2, which is tan 78 degree. We are still going to put it on tabular form. I just want to put it there so that we won't what? We won't forget. So that when we are collecting our values, we'll be able to what? Remember now. So now here we have 1 divided by 1.5. So the 4 decimal place we have what? 0.666. 3 decimal place. Okay. 7 now. So let's just leave it as what? 0.667 now. We are still going to what? 4 decimal place. We are still going to approximate later. So this one is tan what? Tan 78. Tan 78 degree. We have what? Tan 78 degree give us 4 point. So having done table of value, as you can see here, we have the SN, the x in centimeter, the x inverse in what? In per centimeter, the what? Theta 1, theta 2, and tan theta 2. So now these are all expressed in 3 decimal what? In 3 decimal places. So you must ensure that you have what? The same number of what? Decimal places. Now, having done this, now we have to plot a graph with tan theta 2 on the vertical axis and x inverse on the horizontal axis. We have to plot a graph of tan theta against x inverse. So the graph of tan theta against what? Against x inverse. So graph of tan theta against x inverse, that is per centimeter. So now that's the graph we are asked to plot. Now looking at this now, let's quickly what? Obtain our plotted value now, because we cannot just plot to what? 3 decimal place. So we need to what? Find what to plot on the what? On the graph. So 1, 2, 3, 4, then 5. Now, for what? For the tan now, you can have the highest number here for the tan theta now, which is tan 2 theta. So tan 2 theta now. So don't forget that the theta are the same thing. The theta, both theta are the same thing. So now tan 2 theta now, which is what? Which the highest number here is 4.7. 4.7. The highest number is 4.7, meaning that you can use what? For the vertical axis, you can use 0.02 times what? Times 10 to give what? Times 10 will give us 2.0. But if you use 0.05, 0.05 now we get us to what? 0.5. 0.5, that is 2 centimeter represent what? 0.5. 2 centimeter represent 0.5 units on tan 2 theta axis. So now that's because we are going to 5, so easily we can easily get to 5. So using counting from here now, we have what? We have, let's say this is what? Let's even start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have what? 10. So now let me quickly what? Adjust my what point here. My unit here should be what? 2 centimeter represents what? 0.5 units on what? On the tan 2 theta axis. So now the next one is now what? The other one, which is what? Which is the, we have what? The x inverse. The x inverse. So what are the x inverse? What does inverse involve? X inverse, the highest number under x inverse is 0.6. So if you use 0.05, here you should be able to get to the point 0.05. So 0.05 times 10 we give you 0.5. You'll be able to get there. Okay, let's use 0.1. 0.1, 0.2, 0.3, so we'll be able to get to 0.7. So now, if we are using what 0.1, so this means what? 2 centimeter now. 2 centimeter represents 0.1 per centimeter on x inverse what? R6. So let's begin to what? Fix our value now. So here, we said that we should leave this one now. From here we have what? 1, 2, 3, 4, 5, 6, 7. Okay, let's start from here. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now this is 0.0 now. So now let's leave this point here so that we can have space here. So we have what? This is 0.5. Don't forget, this is 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5. Then we have 5.0. So 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, 4.0, 4.5. So this one is tan theta 2. So why this one is okay? This one is 0, 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. So can easily stop there. And this x inverse so that's that. So now don't mind my ruler, so let's use this one for now. So that's that about the what. Now we have fixed the what, the vertical and horizontal axis. Now let's begin to fix the points. Now here we can locate how many decimal places here now. Can locate what, this one 4.7. Don't forget this one is on vertical, it's supposed to be on horizontal. 4.7, 2.7, 2.1, 1.7, 1.2. That x reverse, so it's our x reverse 0.67. You can locate two decimal places here. Now 0.40, 0.29, 0.22, 0.17. Now the first point here is 4.6 against 0.67. 4.67 rather, or 4.7. So we know that, don't forget that this is 4.0, is 4.5. Now this one is 0.5 now, so we need that what? Each line is 0.0, each box is 0.005. So two boxes now will be 0.what? Two boxes will be 0.05 times 2, 0.10. So now this is 4.7, so we have what? 4.6, 4.7. So this is 4.7 against 0.67. 4.7 against 4.7 against 0.67. 0.67 will be what? 0.65 here. 0.66, 0.67. We trace this one up. To this point now we have a point here. I have a meeting point here. So that's number one now. So the next one is what? The next one is 2.7 now. We have 2.7, this is 2.7, 2.6, 2.7 here against what? 0.4. 2.7 against 0.4, 2.7 against 0.4, 2.7 against 0.4. So this is the point here. So I is 0.4. Now 2.1 against 0.29, 2.1 against 0.29, 2.1 against 0.29. 0.29 is here. 0.29 against 2.1. 0.29 against 2.1 is here. So now the next one is 1.7 against 0.22. 1.7 is 1.5 here. 1.7 is here. 1.6, 1.7. 1.0 against 0.22. So we have another point here. And the last one, okay. 1.2 against 0.17. 1.2, 1.1, 1.2 against 1.17. This is 1. 1.5, 1.17. We have another point. 1.17 is there. .2 against 1.17. This is 1.717 against 1.2. So that's that about that. Now let's plot the graph. Let's draw the straight line. It takes these three perfectly well. So leaving one point at the below. I won't be able to draw what slope. So this is my slope now. I won't be able to draw the long line as I used to because of the ruler I'm using, but I will try. So now let's draw the slope. You can see leave 1 point on the top and 1 point, meaning that it's a graph that is very, very what? Okay. Now we have what? Now let's pick a point here. Okay, now without this, even though I don't want to pick a bigger graph, bigger slope, but so this is my what? Slope now. I need to pick this point. So now we have our what? Our tan theta 2, then our tan theta 1 now, theta 2 1, our theta 2 1, and our tan theta 2 2. Now, and this one, our x inverse 2, and then our x inverse 1. So the slope now, we have the slope s will be equal to change in tan theta 2 all over what? Change in x inverse. So we need that what? X is equal to what? Tan theta 2 2 minus tan theta 2 1 all over x inverse 2 minus x inverse 1. So x is equal to what is tan 2 2? Now we have what? This is what? 3.5, 3.6, 3.7. Instead of what? 3.8, now we have 3.75. 3.75 minus 3.75 minus what do we have here? This is 0, 1.0, 1.0, 1.05, 1.10. So 1.10, 1.12. So this is 1.10, 1.10 all over. Then we have what? We have x inverse 2, which is 0. Now we have what? 0.55, 0.52, 53, 54. So we have what? 0.55, 56, 57, 58, 0.58, 0.58 minus. Now we have what? This is 0.1 here, 0.11, 0.12. This one is 0.12. So this is what? In what? Centimeter inverse. Centimeter inverse. So with this now, we can easily calculate our answer. We have 3.75 minus 1.10. We have 2.65 all over. Then 0.58 minus 0.12. We have what? 0.46. So per centimeter. So now we have 2.65 now, 2.65 divided by 0.46. So we have our answer to be 5.76 centimeter, which is approximately 6 centimeter. So now this is used to determine the middle of what? Of the mirror that we want to use. Now, and that's that about what slope. They might ask us to state the precaution taken while carrying out the experiment. Number one is that I ensure that my optical pin are vertically erected, and also avoid error due to to parallax. Also, questions that might likely be asked is that states the laws of reflection of light. The first thing is that the angle of incidence is equal to the angle of reflection. That's the first law of law of reflection. The first law of reflection is that the angle of incidence is equal to the angle of reflection. So that is the angle of incidence is equal to the angle of reflection. Now this angle of incidence is angle of reflection. Now the second law is that the reflection rate, the incidence rate and normal lies on the same plane. That is the second law, and that's about that. List 4 application of plane mirrors. When I'm talking about where we can apply the principle of plane mirror, we have telescope, we have ordinary mirror, and we have sectant. We can apply mirror in this. So, and that's that. We have come to the end of today's class. Please, if you haven't subscribed, please do press subscribe button and the notification bell, and that's all our educated videos online. And share this video to your friends, families, relatives, and colleagues. See you next time. God bless you.